Hello Math 1, I've got a new video for you. It's over section 2.8. We're going to continue this whole idea of writing the equation before we have to solve it. So I've got two really basic types of problems to throw at you. One is consecutive integer problems, and one is what I'd like to call like a starting point rate of change type problem. So let's get to it. So the first three examples are basically going to be like, hey, find three consecutive integers, odd integers, even integers, whatever the case may be, that have a sum or add up to a certain number. So the first thing I want to do is clarify what I mean by integers. Integers are all the positive and negative whole numbers with 0. So we could say it's sort of like -4, -3, -2, -1, 0, 1, 2, 3, 4. And every whole number that continues in that direction on the number line, there's a little dot, dot, dot there. And then every negative number that precedes -4, every one that comes before that. So we're really talking about, I'm not wanting decimal answers in here. You shouldn't be getting decimal answers. They should all be whole numbers, either positive or negative, and maybe even including 0. So when it says three consecutive integers that have a sum of 228, what I want you guys to be able to do is say, let's let n equal the first integer. Okay? So n plus some second integer plus a third integer is supposed to add up to 228. Now here's the key. If you say n is your first one, you instantly can just add 1 to that to get the second integer. Think about this. If 50 were sort of like a random integer that we would have as our n, how would you get to the next consecutive integer? Well, the next consecutive integer is 51. All I got to do is take my n and add 1 to it. How do I get my next consecutive integer? Well, I take my n plus 1 and I add 1 more to that, n plus 2. How would I get my fourth consecutive integer? I just add another 1 to that and get n plus 3. So hopefully this kind of establishes some kind of pattern for you to make sense of this part of the video. So my first integer is n. My second integer is n plus 1. So in place of this question mark, I'm going to put n plus 1 as my second integer. And my third integer is just going to be n plus 2. So here's the equation that you could use to find three consecutive integers. Here's my first one, here's my second one, here's my third one that add up to 228. Yeah, and once you establish what the equation is, it's usually a pretty easy one to solve. Combine the like terms. 1n plus 1n plus 1n is 3n. Okay, so I took care of these. You're left with 1 plus 2, which is 3. Get n by itself. So subtract 3 from both sides. 3n is equal to 225. Divide both sides by 3. 225 divided by 3, if we've got to go off to the side to figure out that calculation, we got plenty of room to do so. 3 goes into 2 0 times, so I got to move to the next digit. 3 goes into 22 7 times. 7 times 3 is 21. Subtract the 2. 1 is the difference. Drop the 5 to get 15. It's 75. And it's exactly 75. So n equals 75. Now that's not our final answer. If you notice, it says, find three consecutive integers that have a sum of 228. I found the first one. The first one is 75. So we've got 75, then 75 plus 1, which is 76, and then 75 plus 2, which is 77. All right, now you might still be a little confused with that, so I'm going to try another one that has a slight difference to it. All right, this one's different. It says, find 3 consecutive odd integers with a sum of negative 117. So think about what odd numbers look like. Let's see, 1, 3, 5, 7, 9, 11. Those are odd integers. Now, we can still say let the first integer be n. Okay? Right? So n plus something, right, plus something else is going to add up to negative 117. Ask yourself, how would I get from 1 to 3? I'd add 2. Oh, it's not n plus 1, it's n plus 2 for the next one. So here's my first integer. Here's my second odd integer. Now, how would you get from 3 to 5? Well, you'd add 2 more. So it's like I'm starting at n, I'm adding 2, and then I'm adding 2 more to get to 5. So it's n plus 4. Okay, so hopefully you guys see the pattern. Instead of jumping up 1 every time, it jumps up 2 for consecutive odd integers. So it's 3, my first, my second, my third. They got to add up to negative 117. Combine like terms. So n plus n is 3n. 2 plus 4 is 6. You're still setting it equal to negative 117. And then it's a pretty simple equation to solve from there. Subtract the 6. Make sure you keep in mind that a negative number, subtracting means you add them, same sign, add. So it's negative 123, not negative 111. It's negative 123 equals 3n. Divide by 3. I'll skip the side calculation because I know it's negative 41. Okay? Now don't stop there. It says find 3 consecutive odd integers. We found one of the odd integers. Okay, we found n. So it's negative 41 is our first one. Now add 2 to that. Now a common mistake that students make is they want to call this negative 43 when they add 2 to it. But when you add positive 2 to negative 41, it actually becomes negative 39. Okay, so the consecutive odd integers are going to be negative 41, negative 39, and negative 37. For this particular problem. So your answers, negative 41, negative 39, negative 37. All right, so we've talked about consecutive integers, consecutive odd integers. Now what about consecutive even integers? Well, this one's got 4 now, and like I said, let's figure out what it looks like when you're dealing with evens. So again, I'm just going to ask you guys to think about what even numbers look like. 2, 4, 6, 8, 10, 12, 14. Now we can still let the first digit be n, so we're playing around with this. Let's say n is equal to 2. Okay? How do you get from 2 to 4? Well, some students will just say it's 2n, which is technically true, but you need to be able to get from 2 to 4 to 6, and if you say 2n, it gets really confusing where to go from there. So I'm just going to say, how do you get from n to 4 using addition? I add 2. How do I get from 4 to 6? I add 2 more. How do I get from 6 to 8? I add 2 more. And it pretty much follows that pattern that if it's an even integer and we're looking at them in succession, you're just adding 2 to the previous one. And it works exactly like the consecutive odd integer problems. So that's helpful. They're both identical. N is my first integer. N plus 2 is my second. N plus 4 is my third. N plus 6 is my fourth. I've got my 4 consecutive even integers, and they have to add to negative 628. So collect your like terms. 1, 2, 3, 4 n's. 2 plus 4 is 6. 6 plus 6 is 12. And again, just solve it like normal. So subtract 12 from both sides, and you get 4n is equal to negative. Again, same sign means add the 2, so this is going to end up being negative 640. Divide both sides by 4. N is equal to, let's do that calculation off to the side. 4 goes into 6 exactly 1 time. Subtract them, 2, drop the 4. 6 goes into 24 exactly 6 times. So don't forget, when you subtract, you still got to drop that digit down and say 4 goes into 0 a 0 number of times. All right, we found our first integer. It's negative 160. Remember, a negative divided by a positive is a negative. And then hopefully at this point you guys have seen the pattern. If they're negative numbers and they're jumping plus 2 every time, then the digit actually goes down. It's going to be negative 160, followed by negative 158, followed by negative 156, followed by negative 154. All right. So I'm going to stop the video there because it's a really good place to just say, hey, those were consecutive integer problems, which are very different from the ones that are going to be on number 4 and number 5.